So in this video, we will cover how to write an assembly language program to divide 8-bit by 8-bit number. So we require two 8-bit numbers in our program so that we are declaring these two numbers, that is number 1 and number 2, in our data segment. So with the help of this DB directive, that is defined by directive, we are declaring this number 1 and number 2 as 09 and 02H respectively. The first line of our code is dot model small. So with the help of this small memory model, we are declaring this data segment and our code segment in one program code segment. So in this code segment, we have written these two lines for initializing the data segment in our code segment. So we are copying this address of that data segment in our AX register, and the values of AX will be copied into our data segment. So we are assigning the values of our physical segment to our logical segment. Now next one, what is the next line of our code? That is move h, 00h and move bh, 00h. So this AH and BH, these contents will be clear and that will be 0, 0. Now the next one is move AL, number 1. So we are copying the contents of number 1 into our AL register. So number 1 is 09. So we are writing here 09. So after executing this instruction, our contents of AL becomes 09. Now next one is move BL, number 2. So the value of our number 2, that is 02, will be copied into our BL register. So now our BL becomes 02. Now what is the next statement? That is division BL. So what this instruction can do? First of all, we have to check the source register. So our source register is BL and BL is a 8-bit number. So we have to check this operation that is given in that division instruction. So the first operation is if the source is byte and the second operation is if the source is word. So first of all, we have to check this our source. This division instruction will be written as division and then source. And here we have written that is division BL. So our BL is a 8-bit register. So we can consider this as our program consists of this first operation, that is if source is byte. So here you can check that if source is byte, then we are storing our quotient in our AL register. And we are storing our remainder in our AH register. So how we are calculating our quotient? That is AL is equal to AL divided by unsigned 8-bit source. So we are writing here AL is equal to AL divided by 8-bit unsigned source. So what is our unsigned source? That is BL. That is we are written in this programming statement. So we are writing here move AL, number 1 and move BL, number 2, and after that we have written division BL. So we are dividing it by AL divided by BL. So we have to put that value, that is AL is equal to 09 and BL is equal to 02. So 9 divided by 2 is equal to 04. So we have stored this 04 as a quotient. And then we have to store the remainder. So for taking the remainder, we have to use this AH register. And we can take it as AL mod BL. And we are putting the values of AL and BL, then we get 09 mod 02. And 09 mod 02 is nothing but number 01. So we got our quotient and our remainder. So in this program, we have taken these two numbers 09 and 02. And after performing this division operation, we got 9 divided by 2 is equal to 4 is the quotient and 1 is the remainder. This is our quotient and this is our remainder. And how we are storing the number in our register? AL consists of values of our quotient and AH consists of values of our remainder. So after performing the division operation 8-bit by 8-bit number, we are storing the contents of quotient in our AL register. So this AL will be replaced with 0, 4. And we are storing the remainder in our AH register. So AH will be replaced with 0, 1. Now with the help of move AH4CH interrupt, that is our DOS interrupt, we are terminating our program. And with the help of integer 21H, our program execution will be ended here. So now we will check these contents in our emulator's screen. So here we have started the execution of our program and we are clicking on that single step mode of our operation. And first of all, our program will execution begins with that move ax at the rate data and move ds comma ax. So we are initializing number 1 and number 2 in this data segment to our code segment. So in this code segment, we are initializing our data segment with the help of these two statements. So here we are passing the address of our data segment into our AX register, and now we are copying this address of our data segment that is already stored in our AX register to our data segment, that is our DS. So here the value is copied into our data segment. Now the next line is we have to clear this value of AH and this value of PH. So we are clearing here the contents, that is 0, 0 in AH register, and now the next line is move BH comma 0, 0 H. So here also we are clearing our BH is equal to 0, 0. Now we have to copy the values of number 1 into our AL register. So here value of number 1 will be 09H. So 09H will be copied into our AL register. The value of number 2 is 02H. So we are copying this content of number 2 into our BL register after writing the statement move BL comma number 2. So here you can check that the value of BL is equal to 02. Now we are performing the division BL instruction. So in that instruction, it will divide the number by AL divided by BL. So after executing the instruction, the quotient will be stored in our AL register and the remainder will be stored in our AH register. So always remember that whenever we are performing the division of 8-bit by 8-bit number, that time our quotient will be stored in our AL register and our remainder will be stored in our AH register. So the contents of AH is equal to 0, 1 and the contents of AL is equal to 0, 4 after performing division operation. Now we have to terminate our program, so that we are calling this move AH comma 4CH, that is our DOS interrupt, and we are taking this DOS interrupt in our AH register. So see here your value of our AH is equal to 4C, and with the help of integer 21H interrupt we are terminating our program. So it will give the instruction to the software, that is you have to terminate our program, and we are using this 21H interrupt as a software interrupt for terminating our execution of our program. And with the help of end of our segment, we are closing our data segment and code segment, and with the help of end, we are terminating our program.